Wonders of the Solar System is a 2010 television series co-produced by the BBC and Science Channel and hosted by physicist Brian Cox. Wonders of the Solar System was first broadcast in the United Kingdom on BBC Two on March 7, 2010. The series comprises 5 episodes, each of which focuses on an aspect of the solar system and features a wonder relevant to the theme. The series was described as one of the most successful to appear on BBC Two in recent years. An accompanying book with the same name was also published. Quick facts. Wonders of the Solar System. Genre. On March 31, 2011, the series won the prestigious George Foster Peabody Award for Excellence in Documentary Filmmaking. Episodes. We live on a world of wonders. A place of astonishing beauty and complexity. We have vast oceans and incredible weather. Giant mountains and breathtaking landscapes. If you think that this is all there is, that our planet exists in magnificent isolation, then you're wrong. We're part of a much wider ecosystem that extends way beyond the top of our atmosphere. As a physicist, I'm fascinated by how the laws of nature that shaped all this also shaped the worlds beyond our home planet. I think we're living through the greatest age of discovery our civilization has known. We've voyaged to the farthest reaches of the solar system. We've photographed strange new worlds, stood in unfamiliar landscapes, tasted alien air. 1. Empire of the Sun. The first episode illustrates how the formation and behavior of the Sun affects each planet in the solar system. During this episode, Cox visits India to view and explain the workings of a total solar eclipse and the partial eclipses that occur on other planets. He travels to the Iguazu Falls to relate the causality between river levels and sunspot fluctuations. An explanation of the Earth's exposure to the power of the Sun occurs in Death Valley, California, USA, with an experiment inspired by John Herschel's actinometer. He also travels to Norway to observe and explain the defensive role of the Earth's magnetosphere against the Sun's solar wind and its role in forming the aurora borealis. He also relates the Voyager missions and their continuing exploration of the massive reach of the Sun's gravitational forces on objects in the farthest regions of the solar system. Finally, in the clear skies of the Atacama Desert, at the Paranal Observatory, he is able to observe, with the naked eye, the myriad of stars on the Milky Way and relates the meaning of their diverse colors as mapped on the Hertzsprung-Russell diagram. 2. Order out of chaos. Cox starts this episode in Al Cairo in Tunisia to analyze the orbit of the planets around our Sun, with details on how the 23-degree tilt of the Earth creates the seasonal weather patterns. He also visits the Atlas Mountains, and relates how in clear night skies the ancients observed the rotation of the stars and the retrograde and prograde motion of Mars and the other wandering planets. In Oklahoma, USA, he discusses the universal reach of the Coriolis effect and the importance of the conservation of angular momentum. Next, at the Jet Propulsion Laboratory, he examines how the Cassini-Huygens space probe's image ray provides an insight on the highly complex structure of the ice rings of Saturn, and its diverse array of moons, and how they can reveal insights into the formation and evolution of the solar system. He also explains how Enceladus, as the most reflective object in the known universe, has been of interest due to its continental divide-like canyons and geysers, as also observed in parts of Iceland. In the Sahara Desert, the formative effect of winds on sand dune morphology is parallel to that of the gravitational effect of Saturn's 61 known moons on the matter that composite the rings, a phenomenon called orbital resonance. 3. The Thin Blue Line. The third episode looks at the atmosphere of the planets and moons of the solar system, with Earth, Mars, and Venus being the main focus. The episode starts with Cox traveling to South Africa and taking a journey in an English electric gliding up to an altitude of 18 kilometers where the thinness and fragility of the atmosphere could be observed in the middle of the day. This is then contrasted with the planet-wide consequences of Mercury's depleted and Venus' broiling greenhouse atmospheres. Later, the diurnal morphology of the Namib Desert is compared to what is known of the surface and depleted atmosphere of Mars, and is used to give an explanation of how the Earth maintains its temperature. Cox then explains how the damaging effect of the Sun's solar wind is deflected by the Earth's magnetosphere. Next, he discusses the transformative effect of weather on a planet's surface, such as the global dust storms on Mars or the electrical storms of Jupiter. The episode continues with an in-depth comparison of Saturn's largest moon, Titan, using data gained from the Huygens probe's January 2005 descent down to the frigid methane surface of the moon. It ends with Cox comparing Earth's hydrological cycle with Titan's meteorological one. 4. Dead or Alive. The fourth episode begins at the Grand Canyon, Arizona, USA, where Cox draws comparisons of the canyon to Mars and the massive Valles Marineris. A trip to Klauan, Hawaii shows the constant geological activity of Earth, and again a comparison to Mars and the massive Olympus Mons is seen. Both comparisons are insightful in the sense that Earth systems are still dynamic and active whereas Mars have gradually slowed into inactivity. Cox then switches view closer to the Sun in the scorched greenhouse planet Venus, a planet often referred to as Earth's twin, and compares it to the Vulcan geology of the Deccan Plateau. An example of Earth's interconnectivity with the solar system reveals that Jupiter's gravitational effect could potentially send an asteroid through the asteroid belt and a collision course with Earth, as evidenced by Meteor Crater. The same gravitational force is also shown to give the Jovian moon Io geological life, given the absence of meteor impact evidence there, as paralleled by the volcanism of Erbil in Ethiopia. All in all, with the universal laws of physics at play throughout the solar system, its interconnectedness can also be seen. 5. Aliens. The final installment covers life surviving in extreme environments, and how the search for life on other worlds follows the search for water. Cox begins by traveling to the deep ocean to draw comparisons between life in the hostile conditions of the deep sea mid, on the submersible DSV Albion, and the parallel potential of non-Earth life. The absence of life-sustaining water in the Atacama Desert in South America is also viewed, which is cited to explain the lack of even basic microbial life there. A trip to the Scatlands in Northwest America is also made, with an explanation of the Missoula floods that once occurred there, and how the telltale signature of water shaped the landscape geologically. The exploration of Mars has revealed possible evidence of its subterranean hydrology, and a visit to the Cueva de Villalobos in Mexico shows how simple life forms, such as archaea and stalactites, survive in hostile conditions beneath the Earth. Conversely, the hostile frozen topography of Jupiter's moon Europa also reveals the presence and effects of subsurface water, and Cox visits a cave in Vatnajökull to find microbial signs of life beneath the ice. Cox concludes by stating that Europa represents the most fascinating and important alien world we know. A true wonder of the solar system because it's our best hope of finding extraterrestrial